Alright, in this video we are looking at finding absolute extrema on a function f, and we're given a graph of the first derivative. Now notice this first derivative graph here, it's bounded between a couple points, alright, 1, -2, and 6, 10. And it's also crossing the x-axis here at 2. So to capture this information, let's make a sign diagram. So we know the derivative is equal to 0 when x is 2. In this portion of the graph down here, we see that our derivative is negative. And up above here, where our derivative is positive, we'll put a plus right there. Now, rather than let our sign diagram go from negative infinity to positive infinity, since we have endpoints of 1 and 6, we're going to cap it off like that, okay? Because that's our restricted domain here for this particular function, okay? So, this tells us that we are going to be decreasing and then increasing. So that means at 2 here, we're going to have a minimum. All right. So the question becomes, well, if we're starting right here at some point, so I'm talking about drawing a potential graph for f, we know that the function is going to decrease, it's going to turn, it's going to reach its minimum, and then it's going to start to increase for a while. The question becomes, well, how do I know where to stop it? Okay, if I'm trying to find an absolute max, do I stop this point above or below my starting point? How do I know? Well, to help us get a feel for where to stop it, what we're actually going to do is we're going to look at the region here, all right, that is below the x-axis, all right, contained between these 2 points. And we're also going to look at this region above, all right. We're going to look at this in a lot more detail later on in the course, okay? But for now, notice how this, please excuse my phone dinging, notice that the region below is a lot less than the region above. So what this actually tells us is that it is going to be increasing longer than it is decreasing. So let's just jot down a few notes here. Down below here, this area, oops, sorry about that. This area is our amount of decrease. And this area up above, this represents our amount of increase. All right? And this is 4f that we're referring to. Okay? It's the amount of increase and decrease for f. Okay? And we could actually go as far as to find the actual area. All right? And again, more on this later on in the course, but it's pretty simple to do now. If we were to find the area of this triangle, okay, this triangle is 1 by 2 for its legs. All right, so that's 2, and then divided by 2, you're going to have an area of 1 for that region. Whereas over here, this is up here, this is 4 by 10, so that's 40. 40 divided by 2 is 20. So this area, and again, I'm just doing area of a triangle, base times height divided by 2. If we compare these two areas, down below you have 1, up above you have 20. So that means your amount of decrease, all right, is, think of it as 1 unit, and then you're going up for 20 units, okay? So what does all this mean? Well, we can conclude definitively that at x equals 6, all right, now we don't know what the y value necessarily is going to be at this point on f. We're just going to say for now that at x equals 6, f has an absolute max. All right, we know it's going to be higher than our other endpoint here. We also can see here that at x equals 2, we're going to have not only a local min, but x equals 2 is our absolute min.